What's up, everyone? It's your boy, the Canologist. We're going to be doing the Leetcode question, swap nodes. So it says basically for every two adjacent nodes, swap. Solve the problem without modifying the values. So basically, we have, okay, it's these, okay, allergies, you know. Okay, so this is the node. So link list, node, link, node, link, node, null. Let's say this is 4 nodes and it goes to end. This is 1, 2, 3, 4. So basically I want to swap every other node. So I can do this. I could just do a 2-pointer method. So 1, and then the other one goes here. And then basically what I want to do is I want to make this pointer, this link, go to 3. And this link go to 1. Then I erase this. Then I want to take this pointer and put it here. And then I want to take this pointer and go to the next. So I can delete this. And I can delete this. So now the pointers are here and the pointer is here. So then I want to flip, because it's every other node, right? So I want to do the same thing again. So I want this node to equal null. And then I want this node to equal 3. It's the link. So all you're doing is rearranging the links. And then basically what you'll have in your result at the end is this. It's going to be 2, 1. So 2 goes to 1. 1 goes to 3. 1 goes to 3. Well, 4 now goes to here, so 1 is now pointing to 4 and 3. It actually makes sense to go backwards. It actually makes sense to go backwards if we look at it. Let's restart. Because if 1 goes to 3, it's still pointing to the 3. 3 is pointing to null. And then 3 is pointing to null. Let's just play it out the way I thought though. So 3 is pointing to null. It's now going to be 4. And then 4 points to 3, and 3 points to null. And then the only thing is we have to figure out how 1 that was pointing to 3 gets pointed to 4 now. Unless the 1 gets pointed next to 4. Because 1, we swap 2. And 1 goes next. One next is 2, so next is 4. So I have to skip 2 to go directly to the 4. So this is next. This is next. So next goes to the 4. And that way 1 goes to the 4 and the 3 gets swapped. And that's how you could get this. So I guess for starters, we got to go 2-pointer. Well, let's look at the constraints too. Let's see what the constraints are. So constraints could be 0 to 100. So if it's 0, nothing to swap. If it's 1, nothing to swap. If it's anything greater than 2, so if head equals if head equals none, output this is just showing you the linked list, but this actually just means none. If head.next equals none, return head. So elif else. So now we're in the else condition where we actually do this is if it's greater than 2. The number of nodes in the list range 0 to 100. So now we gotta go pointer. We gotta create pointers for the head. So ptr1 head. ptr2 equals head dot next. This is the next pointer in the linked list. Let's say if it's 1, 2, 3. Then We could swap the thing and then swap the node. So we swap the things and then swap the nodes where they are. That way the nodes themselves still point to the right thing. So let's try it here. Let's just see if that works. I just have a theory I want to try. And it all comes down to trying your theory out. And if you can get your theory to work, why not, right? Like, you could impose it. So this is 1, 2, 3, 4 going to null. Alright. So this goes to this node, this goes to this node, and so on and so forth till the end. Okay, let's say I get 1, 2, 3, 4. What I want to do is here, these are my 2 pointers, 1, 2. I want to take this node. I want to take the first node, point it to the third. So this one points the link to the third. Okay. Then I want to take this node and point it to the first. So now I should have 2, 1, 3, 4. Okay, so I'm done. Now I want to point my 2 pointers to 3 and 4. I don't know, I could move this and this will move another one. So now I'm here. This is my first pointer. My second pointer will now go to, it'll skip this and go to here. So my second pointer will go to 4, which goes to null. Once again, this pointer will skip the middle and go to 4. And go to 4. And then I want to take this and go to 3. So now I have what the hell? Two, 1, 4, right? And then I have 3. And this is pointed here. So now I move my thing here. One. So 1 is on 4 now, and 2 is going to also be on 4. Well, 2 needs to skip. Two equals 1 dot next 4. So dot next is 4. If 1, the first pointer, equals 2, that means we've reached the end because it's coming back. So 1 equals 1 dot next. So now we go to 3. So now we make this 1 because there's a feedback loop, and then 1 equals 1 dot next, 1 dot next, because now it's this equals no. So that corrects whatever's on the last one. I believe this is a solution. You start with 1 ahead, and 1 keeps incrementing, the other one skips 1. 1 keeps incrementing, the other one skips 1. 1 keeps incrementing, the other one skips 1, but it comes back to the original. So if 1 is equal to the other one, then we just increment 1 and make the next one null, and we're done. That's how we know we're done. So we're always going to check to see if 1 and 2 are the same. I think that's the strategy I want to go. So PTR1, PTR2. This is me just like going through the logic. That's some old boba from earlier today. So I'm going to do a while loop, and I'm going to say while PTR1 is not equal to PTR2. And then I just proceed with my logic. So I'll start with the first one. PTR1 skips a node. So PTR1 dot next. So we go here, there's only the value and dot next. The actual value itself doesn't matter. It says in the constraint that you can't swap values. So we actually have to swap using the links in the link list, and actually swap the link. And then like you saw here, it turns in from this to this to this. So PTR1.next equals, so this would be .next. So PTR1.next equals .next, which is 3. Next. So next. So I skip 1. And then PTR2 Do I have to do it with head? Because if I do ptr1 equals head, this is just a copy. How about I do this? Once I define these, I'll say head equals ptr2. And that way, once all the links are done, it's just going to refer back to ptr2, to this 2. And then 2 leads to the rest, so I'm not concerned. So first I define these pointers, 1 and 2. I'll make the head the second one because we know that's going to be the swapped point. And like here, once we have this address, we just have to follow the list down to get the rest. That's my logic for it. So ptr1.next equals ptr1.next.next. Okay, cool. Now we can go ptr2 links to ptr1. ptr2.next equals ptr1. So I'm just tracing my logic. So I go here first, then I go back here. Cool. And then I shift the 2 pointers. Oh, well, it's already swapped. Next is 3. So I guess then we want to go to 3. Okay, so first I got ptr1 .next equals this. Okay, cool. ptr2 .next equals ptr1. Okay. So let's swap. Now we get 2, 1, 3, 4. Yeah, so technically 3 and 4 would be in the same spot. Because 1 would be pointed to 3, 3 would be pointed to 4. Now I want to swap. So ptr2 equals ptr1, which is now here, .next 3.next. And then what happens to PTR1? No, PTR1 dot next dot next. PTR2 equals PTR1. Now I want to make PTR1 stay the same, and PTR2 equals PTR1 dot next dot next. Yeah, so PTR2 equals PTR1 dot next dot next. Now this goes to the 4, right? And the PTR1 dot next, which is right now pointed to 3, goes to, because it's still on 1 dot next dot next. So I go 1, 2, 3, 4, and then I go 2, 1. This link goes to 4, so this link is already at 3. Let's erase all these unnecessary lines. Actually, wait, let's Control Z that. Let's erase these unnecessary lines. This would be so now it's 2, 1, 3, 4. 2, 1, 3, 4. Now I want to swap 3 and 4. Right, so after I do this swap, I need to somehow increment so I do the swap. I reposition pointer 2. So pointer 2 is now here. I point the next node to 4. I want it to be on 3. Okay, so this is where it is. This is where it is. Okay, so right now it's here. I position this at 4, so this is dot next, which is correct. Then I create a temp. Which is this 3. So temp equals PTR1 dot next. Right. Let's call this temp. Then I want to take this, so PTR1 dot next, and actually put it to 4. And put it to 4. And then 4.next goes to 1. Well, yeah, 4.next goes to 3. Goes to temp. So temp equals ptr1.next. Okay, so now this is temp. Then I go ptr1.next.next. Because I need a way to increment this. That's the thing. Once I increment, I need to somehow push it to 3. So I swap. I get here 1, 2, 3. Or let's go back to the drawing board. Let's go 2, 3. Two is ptr1.next.next, so that's 4. I want this here, so I can redirect it, right? And then the other thing is if I move this here, I can't adjust this arrow. So what I'm going to do is temp equals ptr1.next, so that's here. ptr1 so this is temp ptr1 dot next equals this equals dot next. So send this to 4, and then ptr1 equals temp. That way we reposition 1 and we reposition 2. So now the only thing that so this is now one, and this is now 4. So now it's pointing to this. And then we just continue until you hit a feedback loop. So eventually 4 is going to be equal to 1. So if ptr1 equals 2, and then you just return the original head. The ptr1 equals ptr2, ptr1 equals ptr1.next to get null. Because right now it's going to be dot next equals no. So now it's going to be dot next equals no. So right now it's 2, 1, 3, 4. So dot next is no. Let's delete this. So skip 4. And then 4 dot next is going to be equal to 3. Boom. Oh, so we don't even have to do anything. I don't even have to do this base case if it's done correctly. And let's just say if ptr1 so while ptr1 dot next is not equal to null, none, then I just go here and return the head, because now everything's swapped. So I just return the new head node, which is ptr2, which I'm just going to call head. So this should work, unless there's something with the links I messed up. None type has no attribute next. Okay, so something's off here. ptr2 equals ptr1 dot next. What's my time at? Okay, I'm at 38 minutes. Okay, let's just ChatGPT fix my logic. But you guys see what I'm trying to do here using this logic. It's probably something really minuscule. So let's go here, constraints, Control C, ChatGPT, because I just want to be time efficient. I'm trying to get through, I have to do another 50, like 40 something of these for this playlist, so I'm just gonna speed through. At least as long as you understand to do it on the whiteboard, that's like the main takeaway. That means you understand the logic. The rest is like syntactical sugar. My code. And you guys could pretty much see how this works. Because if this goes here, this goes here, and it's 2. Then it just becomes 2, 1, 4, 3, null. 2, 1, 4, 3, null. Going this way. So I'm pretty confident, as long as you kind of can logic your way through it and draw it out and articulate your thought. It means you're not just blindly solving the question, right? You understand and you have an idea, and you're turning your idea into code here by putting your logic that you've implemented here on the whiteboard into this code editor. So fix my solution. The key is the original implementation, how you're managing the node references during the swapping, okay, and how you update the pointers, okay, especially in the loop. Here's the improved approach. First node is current.next, okay, cool. Okay, so it combines my 2 if statements into one. So basically this, because if head is none, or head.next is none, so basically it's saying If head is none, I could just say or. Head.next, I could just return the head itself. Because if it's equal to none, I just return the head. So if this, then I could remove the else statement. Right, and shift tab it. Okay, cool. Now we have this is my new script. Okay, let's see what's going on now. So new head equals head.next. Perfect. And that's what I did here. New head equals head.next. Or head, yeah, you could just make it head.next. Head equals actually, I'm fine with this. Head.next, and then what does it have here? Previous is none, current is head. Oh, so I was going one in the next. This is going one in the previous, so it's previous and thing. Solve it, keeping my code structure. Okay, perfect. So PTR1 is not none and PTR2 is not none. Okay, cool. PTR1 is not none. I could do that. Okay, cool. Temp equals PTR2.next. Save the pairs for next. Save the next pair's first node. So temp equals ptr2.next. Okay, cool. ptr2.next equals ptr1. Swap the current pair. Dot next equals ptr1. Okay. And then this one is. Oh, it's using ptr2.next because I'm using ptr1.next.next, right? So it's literally the same thing. So I'm gonna go temp equals ptr2.next. So this .next is 3. I'm gonna keep that here. ptr2.next equals ptr1. I already have that. Perfect. Check if there's a next pair to swap. If temp is none, or temp.next is none, then point to it. Okay, cool. If temp is none or temp.next is none, then we want to go ptr1 ptr1.next is equal to temp and then break. and then break. So basically it's saying, if this ended here, right? PTR2 is next, so temp is null, or dot next is null, then we're done. We don't have to do anything. Otherwise, now we have to update everything. PTR1.next is temp.next, okay, cool. And I did that here by going .next, so PTR1 and then PTR1 equals temp. Nice. Okay, so I already did that. Link to the next pair's second node. Yep. Move PTR to the pair's first node. Yep. And then move to the pair's second node. Yeah, so PTR2 equals PTR1.next. So basically, instead of going .next, they're just referencing directly from PTR2, which is the difference between mine. I reference from PTR1, which is just to the left. So this is just to the right. That's why they can just go .next. I went from PTR1 .next, where it's pretty much the same thing. And then you return the head node. I guess the only major difference would be here, where they're checking for the next node and breaking out of the loop immediately after. So they're doing the check in the middle, like right here. Let's just confirm I typed it correctly and no errors. What did I do? Did I say if head equals none? Head.next. Oh. So dumb. Oh my gosh. See, it's always like some small little syntactical thing. So if I submit this, and there you go, beats 47.3% of solutions. So as you can see, it all really kind of goes back to kind of tracing out your logic on the whiteboard. If you can do that, then you can kind of translate that into code. Then you can solve the question intuitively, right? So a lot of it is just kind of drawing it out. If you can't do it on here, like if you can't get to this conclusion, that's where the issue is, because now your thought process about the question is wrong, right? The other stuff you can get guided, or you can look at resources and things like that, but like if you don't have this base logic down of how a linked list works, like there's a node, there's a next pointer, and how to manipulate this, that's where the trouble is going to happen. So I'd say focus on this part first. If you can get that whiteboard part first correct, the rest can kind of be solved. You see? And yeah, with a bit of guidance, ChatGPT just cleans up my code, right? Because there's always something small that I might have missed, right? As you can see, I didn't even include this part by accident. So beats 47.3%, beats passes all the tests and submissions. So if you like this, please give it a thumbs up, subscribe, comment below. Knologist out.